Okay, today our main job is discussing sum notation. Now I want to kind of talk about what the next few days is like. Today is this file, tomorrow is also more about sum notation. And that's that sigma. Have you guys seen this symbol before? Sometimes there's little thingies like that. It's a sigma letter. Anyway, it's about that for today and tomorrow. And then that brings us to Wednesday. Wednesday and Thursday we will be doing 9.3, which is just another section of this. There's actually up to like 9.6, so we aren't anywhere near ready for the test. Okay, so by the end of this like short week, we're going to be done on Thursday, right? You are not having a test anytime soon. Okay, so this week is just learn new stuff each day. Okay, so if you are missing Thursday, which is a decent number of people, I am teaching a normal lesson that day. You will have to watch that over break and get caught up. But then again, the trade-off is you got to take Thursday off, and I don't get to take Thursday off, so I don't feel that bad for you. So who all in here is missing on Thursday? It's usually several. Oh, it's only one or two. Okay, good. Now you know what to do. It'll be a normal lesson on Thursday. All right. Then when we come back, you'll have had your luxurious, well, it sounds better if we just say the total number of days. It is like 13 or 14 days. It's not that bad. I know it could have been better. Yeah, because we had 2 weeks, 2 full weeks plus the weekends on both ends off last year. I get it's not as good as that, but at least here's the positive side. I want you to think this through. I get a lot of schools don't have school on Thursday. A lot of schools go to Wednesday and then stop. I know there's some schools that don't have any school this week at all. I get that, but got to think of it this way. Minnetonka has always had the same number of school days for a bazillion years in a row. Like since you were a kindergartner, you've always had a certain number of school days. It's usually in the neighborhood of 180. Okay, if you want to feel whiny about anything, it can be that every single year we have more school days than we have to have. By law, you only have to have like 165, and we have like 180. I'm totally using round numbers here. Those are not exact, but bottom line, we have way more days than we have to have. That's just the way it is. But Minnetonka wants you to have a better education, then I get you could argue that if we took 2 weeks off the school year that you'd be fine, but this is a decision that your parents, the taxpayers, and the school board, and realistically who's in charge, but they answer to your parents, the taxpayers, that they want you to have a good education. And so, bottom line, you are going to have like 180 days, so by teaching these 4 days, we don't have to go deeper into the summer. There are some years they make that decision, and those years you get out on like the 14th or the 15th of summer, which is really on the late edge. I've been here when we've had those, so you have had those in your elementary days. You probably didn't even know what day it was, but when you were a little elementary kid, sometimes you got out in the middle of June. We're getting out earlier in June because of this. So yes.
Do we have a student rep in the school board?
Good question. No, the school board does not have, all of them are like adults that are voted in by the community. You have to be age, I think, 18. So does the school board listen to comments? Absolutely. And if enough kids, oh yes they do. They listen. That doesn't mean they always just say yes to whatever you want, because kids would unite and say no homework.
Okay, but
teachers have, teachers don't have permission to assign any homework from them.
Talk about how they don't want to have a week that's shorter than 3 days, that's why we'll always have school on the Wednesday. So why would they make it a 4-day week this time? Because that's always how they do it. They'll be like, all right, we have school up until Wednesday, and most schools will always have that Wednesday off.
Yeah,
we don't want to have it shorter than a 3-day week.
So you're saying that the school's policy is to not have 2-day weeks, right? Because 2-day weeks, why not? Why even have the week at that point? Because so many kids will take the week off, right? So, but why is it wrong to go to Thursday?
Think about the amount of kids that are going to be gone. It's the day before Christmas Eve.
That's true. No matter when though, I'll give you this experience from my experience. Like let's say we had 2 weeks off, I guarantee you there'd be a small subset of parents who would take the day before, whatever the time is. They'll always take that day before off to go on their trip a little early, because a lot of times, and I get this as a parent who has to pay for airfares for my family and stuff, if you go like 2 days before, a lot of times the airfare can be like $100 per person cheaper, and you got a family of 5, it'll save you $500. You're going to be like, yeah, we're taking that day off. So anyway, So enough about that. Let's not have any more complaints about why we are in school today. Let's just get to learning the new stuff. So here is a little sigma dealy bob. And if I go like this, that means I want the first, second, third, and the fourth term of this. And here's how they would say it. 2n plus 5. And then you could say n equals 1, 2, and just to save time, they don't write n equals 4, but it's the same idea as that. Now I'd like you to write me what are the first four terms. Just find the first four terms. Because this is not only a term generator, it'll tell you what term 1 is when you stick in a 1, and what term 2 is when you stick in a 2. It also is telling you, no, commanding you to add them all up. That's what that little sigma sign means. It always means that you are adding up each of those terms. However many there are, if it's got a sigma in there, it's saying add them all up. So don't just find the terms and put commas between them. You find the terms and put a plus in between them. So by now I'm hoping you've stuck in a 1 and you figured out that it's 2 times 1 is 2 plus 5 is 7. 7 is your first term, right? But instead of putting commas between the terms, it's 7, and then you're going to add the next term, which was sticking a 2. 4 plus 5 is 9, plus, then you're going to add the next term. I'm going to stick in a 3. 6 plus 5 is 11. And could you have just like stopped looking back at the formula? Yeah, because by now I hope you figured out you're adding 2 each time. So this is when you stuck in 1. This is when you stuck in 2. This is when you stuck in 3. Here's where you're sticking in 4. And that's just to add 2 more is 13. Now, can I add them up by hand? Absolutely. And it's a way that works. And as long as there isn't too many terms, it's not that bad. I'd start by adding those two because they add up so nice. What do they make? 20. 33 plus 7, 40 is your answer to this. It's a sigma notation, okay? But what you just did, is that a sequence or is that a series? It's a series. A sequence is this. That's a sequence. A series is where you actually take those numbers and add them all up. Okay? So this is a sequence. A series, it would be this. Okay. So now, let's do another one like that, just by yourself. See if you can do this without needing me. If I go from, notice I can make this bottom thing i's or n's or anything I want. Okay? Find the answer. I'll pause while you try that one. Okay, so this should have generated some terms for you. You stuck in 1 and you got 2 times 1 is 2. You stuck in 2 and you got 4. And you stuck in 3 and you got 6. And you stuck in 4 and you got 8. And you stuck in 5 and you got 10. And there you go. But did I write that correctly? No, because that is actually a sequence. And what we have is a series, which is 2 plus 4 plus 6 plus 8 plus 10. All right. Now, there is a formula for doing this. You might be thinking, do I have to just like keep a... Yes, there is a way to do this. And it's Friedrich's way, which is you take that, and what do they add up to? 10 plus 2, 12. And then the 4 plus the 8 would also add up to 12. And that formula could even handle the odd leftover term like this. I'll show you what the formula is. You do need to write this down. You do need to know this formula and be able to use it. You start with the first term. And what did Friedrich add? The last term. But the last term isn't just written as like a sub 14 or whatever. We have to write it in terms that we already know, which are the last term is given by a sub 0 plus d times n minus 1. Does that ring a bell? That's the formula that you already knew for a sub n. A sub n was a sub 0 plus d times n minus 1. So all I did was put this here, and now we've added the first plus the last, and then that whole thing, notice parentheses around the whole thing, I have to multiply by however many terms there were, divided by 2. There is the formula for S sub n, the sum of a bunch of numbers. And this formula is giving you the first plus the last and timesing it by how many there are divided by 2. You're used to that. You already know how to do it. So do you have to memorize this whole formula? No, but you'd have to know how to use it. So let's try to use this formula to add these up. 2 plus 8 is 10, plus 8 is 18, dot, dot, dot. And we're going to do that for the first 15 terms. Actually, make it 16, because it'll be so much nicer in your formula. Go ahead and use that formula we just kind of summed up. It's just Friedrich's formula, except written out in general terms. Do you get that's 2 for the first one? Plus, if I want the 16 terms, I got to put in 16 here. And the difference each time is 8. And the amount I started with was 2. So then it's going to be 8 times 16 minus 1 is 15. 15 times 8 plus 2. And then the 15 times 8, 120 plus 2 is 122. Did anybody verify the 122? Did I do that right? Okay, good. Thank you. And then I have to multiply this whole thing, that was the first term and the last term, by n over 2. There were 16 of them. That's why I picked 16, because 16 divided by 2 works out nice. And that comes out to 8. So now I'm going to go 8 times 124 will give me my final answer. I personally like doing that like this. 100 plus 20 plus 4. And I go 8 times the 100 is 800. 8 times the 20 is 160. And 8 times the 4 is 32. And that can let me do this in my head a lot easier. 8 times 124 is 998. Oh, dang it. 900.
You said 32 and then you wrote.
Oh, thank you. Okay. So 960, 992 then? Is that right? Okay, good. Okay. So that is arithmetic, and that's Friedrich's method summed up with a formula. All right, so I have one more formula like that to show you. And I want to see who can handle this. Now, I know some of you will not be able to, and it's okay. You can just get the formula I get at the end, and that's okay. But some of you like a challenge, and you might be interested in how I can prove this works. This is the formula for summing. Didn't I just do this one? Yeah, but what haven't I done? I haven't done the right kind for multiplying yet. The one I did before, that was for numbers where you added something each time. Okay? Arithmetic. This is geometric. So let me show you. See if you can hang with this. Some of you will be proud to say, oh, I get what he was saying each time. All right, the sum of a geometric, do you agree we start with a sub 0? You with me so far? We start with a starting number. And do you get that then you multiply by something to get the next one? So if it's a sum, it's really adding the next term. And what would the next term be? Well, you'd take the starting one and you'd times it by, well, what's the name for that thing you multiply by each time? R. Are you with me so far? Okay, now I'm going to add the next term, which is going to be a sub 0 and times by r, and then times by r again to get that third term, right? Or I could think of it as a 0 times r squared. Could I have just said r times r if I wanted to? Sure. Do you get how I times by 1r here? I got it times by r again to get the next one. All right, so now let's see if you can hang with this. There'd be as many as necessary terms. I put dot, dot, dot because we don't know. Kind of depends on the problem how many we do. We might have 35 terms. We might only have 4. But eventually, would you agree it ends with the last term, which was a sub 0 times r to the n minus 1? Does that ring a bell? That's the formula for the last term. All right. Now, here's how you get this geometric, how do you add them all up thing. First, bear with me as I copy laboriously the thing from above. All I'm doing is copying it, and you don't have to prove this whole thing. All I'm doing is copying, though. This is not rocket science. It will be in a second. Do you get, then, that the one underneath it, the green one, is identical to the black one? It is. It's supposed to be, unless I've miscopied it. Okay? Now, I'm going to take the green one and times everything by r. Do you get that I can do that? Just like an equation like 1 plus 4 equals 5, I can times, you know, if I have a normal formula or a normal equation, I can times everything by 2 if I want to. And this is going to be 2 plus 8 is equal to 10. It's okay to do that. I'm timesing by r everywhere. It's a pirate's favorite variable, r. Close rival is, of course, c. You get this funny because the c is kind of like the word sea, like the ocean. Okay, anyways, moving on. So if I take s sub n minus r times s sub n, what did I do? What the heck? He just subtracted that minus that. That's called the elimination method. You learned it when you were younger. I'm subtracting straight down. Equals. Now, this part, I think some of you are going to need to see this. I'm going to put a minus in on everything. Maybe that'll help you understand why I subtracted. I want to put a negative everywhere. Can you do that? Sure, it's just multiplying by negative 1. And that's all one term right there, right? So, okay. I just multiplied everything by a negative. Now the magic happens. That and that can cancel. And do you get how that's actually identical to that? And opposites? And therefore they'll cancel. And all of the terms that are in between, in this sandwich in between, will cancel, except for the very last one. When I multiply this by negative r, this r can be joined in with times r here, and that's like times r to the 1. And when you do that, you add the powers. So this becomes plus 1. Because when you multiply by r, I can add 1 to its power. Okay, so then the minus 1 and the plus 1 cancel. And everything cancels except the very first thing and the very last thing. And so here it is. A sub 0 minus a sub 0 times r to the n, and there was a minus 1 and a plus 1, so they canceled. So there is your big scary formula, except I can simplify it even more. Because if you can factor it, you should, and so s sub n comes out, and I have 1 minus r. And if you can factor it, you should. What's in both of those? A sub 0. And so you have 1 minus r to the n. And then if I was trying to find the sum, that's the thing I want to get alone right there. And so I'm dividing both sides by 1 minus r. And I get s sub n is equal to a sub 0 times, I'm going to multiply these by negative 1, which reverses them, r to the n, 12 minutes left, sum of n terms. And I have just, the last step I'm doing but not saying is I multiplied by negative 1 here and here on the top and the bottom. That's legal. And that switches them around. So there I have given birth to a baby formula. The birth process is painful. Now, it's okay if you don't know where it came from. I tried to show you, but I get that it got a little complicated and messy in there. But the bottom line is this formula will work. For which kind? Geometric. Now, do you get I could have just said, that's the formula. Okay. How many of you, be honest, please. How many of you feel like you benefited by me showing you where it came from? All right. 6, 7 honest souls who said, yes, I actually wanted to know where it came from. Now, it's okay. You don't have to be one of those people. As you get higher in math, if you want to actually be a math major someday in college, you'd have to prove stuff like I just did. You can't just say, oh, well, obviously this works, so I'm going to use it. You have to be able to prove stuff. All right. So if I were going to ask you to use this, now that's more of a pre-calc level thing. So let's actually use this to take these terms. 2 is going to be my starting term, and I'm going to times by 3, and I get 6, and I'm going to times by 3, and I get 18. And so that is a geometric. Yes? Okay. Then, would you please use this to find the sum of the first 10 terms of that? I would not write out all 10 terms and add them up. I would use this formula. Try it. I'll pause while you give that a shot. All right, so here's how you do this. I'm going to stick in a 2 for my starting number. And it's times by 3, right? So that's my ratio, so that's my R. So I would have 2 times my R is 3 to the power of n, which is 10, minus 1, all over R, which is 3, minus 1. So did you have 2 times 3 to the 10th minus 1 all over 2, and then hopefully you're smart enough to know that those 2's can cancel because this is part of a multiply, and then it's just 3 to the 10th minus 1. Raise your hand if you had that one right. Sweet. You have added up the first 10 terms of a geometric sequence, and do you get how big that is? It gets holy crap big. That's why we need a special complicated formula for this one. Can't just add the first one and the last one and then multiply by half the number of terms that there are. That's the other kind, arithmetic. All right, so here is a typical question that sums up, did you learn what you're supposed to for today? How many terms will this one have? Can you tell just already? We should be able to tell. How many terms? 5. How many terms would it have now? 6. I added one because we could stick in a 0. Okay, back to this one. So it's going to have 5 terms. And let's say it had this in it. Wait. What's your gut feeling? Will this one be an arithmetic or a geometric? Geometric, because it's got that R kind of thing going on, where the R was 2. That makes sense? Whereas the simpler kind, like this, what kind is that then? Probably the arithmetic kind. What you're going to be adding each time. You can just look in there and see what you're going to be adding each time, and don't say 4. You're going to be adding 2 each time. How could you tell in this problem that it's arithmetic and you're adding 2 each time? I personally would start by sticking in the 1 and just seeing, oh, this is 2 plus 4. 6 is my starting number. And then I'm going to stick in a 2. And I get 4 plus 4 is 8. Oh, look at that. I added 2. And just to make sure I'm really adding 2, I'd put in one more. 3. 3 times 2 is 6 plus 4 is 10. Oh, yep. Looks like it's going up 2 each time. So now I know it's arithmetic. And it's going up by 2 each time, called D is 2. And then I could use that formula I gave you. Or you could use Friedrich's method just off the top of your head and go, okay, first one, 6, plus the last one in the group. You'd have to go figure out what the last one is. First one plus the last one. Add them together, and then multiply by half of how many there are. In this case, there are 5 of them. So I'd have to multiply by 2.5. Or you can just actually find all 5 terms and add them all up. All right. So do a little bit more new stuff tomorrow, but that's pretty much it for today. So now let's go to find the homework. Question, ma'am?
Yeah, why is it significant, like, in this example today, we're under, what's this, at the bottom of that little,
This thing, like this?
yeah, why?
Okay, it can be I, it can be K, it can be any letter, but that's just that's like the counter. We start with 1 and we go to whatever this is. Okay? All right, so like on this one, we'd start with 1 and we'd go to 5. And you do all the whole numbers in between, like 1, I'd stick into 2, I'd stick into 3, I'd stick into 4, I'd stick into 5. All right, moving on. The homework actually starts on page 40. So keep scrolling way down until you hit the one that looks like that one. It says assignment day 1, and it's green around the edges. You with me? All right, you are doing the whole first page here. They say they take a half a minute. They lie a little bit. Takes a little longer than that, but I'm not assigning too much when it's all done. So those 4 are assigned. Now let's just, my advice anytime you have these is you're not used to these. So I would make a list of the first few terms. Stick in a 4 and go, oh, so you're saying 5 times 4 is 20 plus 23 is my first term. Okay, what I just did there? You get how a sub 0, the first term, is in every formula we have. We got to know what the first term is. So at a minimum, find the first term. And I recommend you find the first 3 terms, because then you'll quickly be able to change this, which looks really confusing, into a nice little list of numbers. My next term, I can even look at that and say, oh, it's going to add 5. It's going to be 28. If you can't do that, then you should stick in a 5 here, and then you go 25 plus 3 makes 28. And I can tell I'm adding 5 each time, so I'm going to say 28 plus 5 is 33. Just to be safe, maybe I should put in a 6 here. 6 times 5 is 30, plus 3 is 33. Once you've done that, now you've made it one you actually understand. You know how these work. You know that that's arithmetic, and that the D is 5. Difference is 5 each time. And you got a formula for that. Okay, moving on to the next page. You're doing all of these except number 4. Everybody cross off number 4. And the next page, you're only going up to 11. So why don't you just draw a line across like this kind of, because starting at number 12, you are not doing those today. We're only doing up until number 11, and that's it. And that should make it a relatively decent evening, considering I taught for a long time today. At least you don't have too much homework to do at home. Tomorrow, you'll have a lot less instruction time and a lot more work time because I don't have too much more I have to teach you for you to do the tougher ones. Okay, that's all I got for you for today.